What's going on YouTube? This is IPSEC, and we're going to be doing another Sherlock today from Hack the Box, which are just defensive challenges. This time it is going to be CrownJewel2, which is a sequel to CrownJewel1. And if you haven't watched that first video, I would highly recommend doing so because I'm not going to cover a lot of the basics again. And also, in the interest of time, I'm going to skip a lot of the recon I normally would do. That is just like looking at all the data in my log file, converting all the event IDs to names and things like that, because it does take time. And I'm going to replace doing that with something I think may be more interesting, and that is writing a rule file in Chainsaw. So then you can use the hunt command and have it auto magically find things, which I think is just amazing. And also it helps me motivate to do these Sherlocks, because as I do the Sherlocks, I create the rule files, and then when I go on engagements, do forensics, I replay those rule files against the data from the engagement, and to discover how good my actual rule was, if there were a lot of false positives or not. If there weren't false positives, then the data I made while I was doing Sherlocks becomes immediately valuable, because it takes a long time to hunt for something if you just don't have some predefined rule set to automatically look over your data. If that doesn't make sense, it'll make sense by the time we're done with this video. So let's just jump into the Sherlock. Let me make myself smaller and we can go over the scenario. The Forella domain environment is pure chaos. It looks like we didn't do a good job cleaning out the attackers in the last one, and they have managed to dump NTDS.DIT yet again. If we look at the Sherlock info page, it does tell us they used NTDSUtil to dump it. It also says it here as well. I recommend reading both the scenario and the info before you begin. And you could also start reading the questions, but I like looking at the data before I go into the questions, because I find if I look at the questions first, it kind of taints the information. And again, on engagements, you don't always know exactly what's happening the first time. So you want your recon, your quick wins to be really on point. So I'm going to use two different tools. The first one, I guess you could have guessed, is going to be Chainsaw. And I've already downloaded it and unzipped it. So I'm going to go opt Chainsaw, and then we're going to execute the binary, specify the hunt, and then we use the mapping flag to put it in opt Chainsaw mappings, and then what is it, sigma event logs all.yaml, and then we got to give it the sigma directory, which is just a lot of just default rules. So do opt Chainsaw sigma, and then custom Chainsaw rules is -- rule opt Chainsaw rules. So if we run this command, it should output a table if we put all the event logs. So I'm going to do star.evtx. So it knows to process the evtx files. And then we got a table. It's a bit hard to read because my font's so big. Let me change that to be smaller. And there we go. The first thing we have is schedule task deletion. And looking at the task name, it's create explorer shell unelevated task. And I think this isn't really that interesting to me. I think this happens all the time. But if you're a defender and know otherwise, something sticks out here, please let me know. There's also a volume shadow copy mount, and we can see device hard disk shadow copy 1 was initiated. And this is suspicious to me. Sometimes environments do use shadow copies, and if you see a lot of these, it may not be suspicious. But it indicating it's the first copy, this is definitely suspicious, because it looks like the domain hasn't been using them before, and the attacker probably created a shadow copy. The reason why they do shadow copies is because this NTDS.DIT file is a protected file. You cannot read it even as administrator. You have to either go into the raw NTFS data and read it, so you bypass some ACLs, or if you create a shadow copy that's a backup file, then you can access it, right? So those are the two main ways people access this database, which again is the Active Directory database. Other files they like accessing over shadow copies is the SAM, which is a part of the registry, the system, all those files, right? I think it's C:\Windows, probably system32 config, or maybe it's just C:\Windows config, and then the file would be called SAM, right? So the registry highs are important, and also NTDS.DIT. But really not all that much information. So I'm going to use a different tool, and that's going to be Hayabusa. And let me make the font bigger. Hopefully this one displays a little bit better. If we execute the binary, we can just run it. If you don't have this tool, I just went to GitHub Hayabusa. Yeah. And it's on the Yamato Security GitHub. So just download the release and unzip it. That's all I did. And then normally I go into the directory and then run it with the update rules command. This is going to make sure all my rules are up to date. And if I ran it when I wasn't in the Hayabusa directory, it would create a directory called rules and put them there. So that's why I always like seeding to this directory before I run the tool, just so everything stays organized. So the next one we want to run, let's see, it's probably going to be a CSV timeline. Let's just go with that. So you can do CSV timeline and then -H to see options. And let's see, what do we have? I'm just going to specify, I want to say it's -D and then the directory for event logs. Let's see, yeah, -D. So we'll do -D, HTB, what is it? CrownJewel2. And that should be all I need. It's going to ask me a few questions. I'm just going to do, let's say, the core rules first. We don't have sysmon logs here, so I do no there. And it found nothing. Okay, let's go and change it up. This time we're going to do core plus. Again, no to sysmon because, again, don't have any. And we got some detections. So looking at this, we have 12 medium detections. And going up, it is all NTDSUtil abuse. So we have dump to a suspicious location. And if we look here, we have C:\Windows temp, dump temp, active directory, NTDS.DIT. So that is why it flagged, right? We also have it just being ran, I guess. Here it's in the shadow copy directory, whatever you want to call that. So just a lot of flags here with this command. We could like go crazy and just say all events and rules and see if it generates anything. I'm just going to do yes to everything and see how much we actually get. It's loading the detection set. It says, please wait. It doesn't take too long. And let's see, we have rare scheduled task creations, deletions, volume shadow copy, credentials enumerated, remote scheduled task creation, NTDSUtil abuse, no critical or high alerts, but this is a pretty cool tool if you don't want to like go deep diving into your logs right away. I like running this just to see what it points out, right? So a lot of group enumeration stuff and things like that. When you do the everything option, obviously there's going to be false positives. It's not all malicious. It's just to give you a quick idea at what is in the log. So let's take a step back and go look at what the questions are, right? So we know there's probably some type of suspicious NTDS.DIT exfil, right? Probably from the NTDSUtil tool because that's what all our tools said. So it wants us to look at the most recent timestamp which this service entered a running state, and that is the Microsoft Shadow Copy service. So remembering from the last crown jewel, that was in the I think system log, and I'm just going to cat a file out of the last video. It's going to be system.txt, and this is where we did all the event IDs, what they mean, and then how much they occurred. And I want to look at a service change state, and that's going to be event ID 7036. So those are the events we want to look at here. So I'm going to do a chainsaw command. So we do opt chainsaw dump, pipe it to JSON star.evtx, and pipe it out to events.json. So now we just have a big old JSON file. We can cat it, then pipe it over to JQ. And actually, what I'm going to do real quick is I'm going to dump it to JSON-L. I think that's JSON log format. And I'm going to show what that does real quick. So if I just do cat events JSON JQ.less, it puts it in this list, and then, it just puts it kind of in a list and does like nesting. The JSON-L format doesn't do nesting. In the last video, I used this to get rid of the nesting. If we look at the logs, it's not there. But what I'm going to do here is change it to do dump JSON-L because I like this format better. So let's now cat events JSON-L. We can less it again. And you can see what it looks like. Every event is just on one line. The log itself is a little bit bigger because, again, the nesting does save space. We can see 1.3 megs instead of 932K, but actually, that's not what I expected. I expected this log to be bigger than this. I don't understand what's going on. I like using JSON-L. It saves one of the list item things. Probably explaining that wrong, but at least you have my reasoning why we switched to JSON-L this video. So what we want to do is grab the system log. So we're going to do event, system, channel, system. So we're going to do a JQ dot and then a select. I'm going to specify dot event here, so I don't have to keep typing event every single time. System dot channel is equal to system, right? I think I did that right. Looking at that, yes, the first event is now system. And then I already forgot what the event code was we wanted. I want to say 7036. Let's see if my memory's good. So I'll do a and dot system event ID is equal to 7036. And let's see, is this good? Yep, it is. So we have param1 and param2. This is the service and the state. So let's dump all those. So I'm going to now say dump.param1.param2. We want to put this in that single quote and a pipe. There we go. We need to do event data. Event data. There we go. So we have stopped running. We probably want to also select when it is running. So we can say and dot system. Oh no, this is going to be event data dot param2 is equal to running, because that's what the question asks, right? Most recent timestamp which the service. Yep, it did. So now that we have running, I'm only going to look at param1, and we're going to get a list of all the services. And let's see, we can grep this for shadow. And we either want the volume shadow copy or shadow copy provider. So what I'm going to do here is we'll go back to select everything. And then I'm going to do a -C. So that puts it all on one line. And I'm going to do a grep-I for volume. And that'll get me the 3 events. And then we can look at the timestamps. So let's see. We have volume shadow copy at 2024 5:15. See this one, 5:15. I don't know exactly what they want, but they wanted the most recent one. So I'm going to try this timestamp. We'll do up to here. I forgot to copy that too. So this is the most recent time volume shadow copy went into a running state. Yeah. Okay, it does not like the T. It wants a space here, and we'll see if this works. It does. Awesome. So identify the full path of the dumped NTDS file. So that's something the hunt command already told us. We want to look at NTDSUtil. If we didn't do the hunt command, we could just Google let's see, NTDSUtil event log. And let's see, we have this page, Velociraptor. What is this? Don't know exactly what this page is. There we go. The Velociraptor is telling us probably event 216, 325, 326, and 327. If we look at the lolbin repository of NTDSUtil, no, this is living on the land, not lolbin. Living on the land binaries, this tells us exactly how to use NTDSUtil. And the one thing I'm noting about this, right, this is why I normally like researching the commands before I do a lot of analysis. We don't see them actually specifying a file name in this. They just specify the directory for the dump to go to, I think. So because they're not specifying a file name, we can just make hunt rules targeted towards files themselves. And we want to look at what these event IDs are. So let's Google, let's see, this is event ID 216. We may have to specify the exact log. This is Windows backup. This looks good. Let's see. Restore failed with errors. Let's look at 325. So event ID 325. see, 327, 326. That's funny that that came up when I searched 325. Let's see. NTDSUtil. The box. I'm not sure exactly what that one is, but we have 327 and 326. A database engine has attached and a database. Are these the same? I thought one would be detached. 327, 326. Let's see. This one has a recovery cache. That is bizarre. I could swear one of those is like NTDSUtil has finished. Let's do 326. Different page. This is the same exact information. All right, so I'm going to go with 326 is it started and 327 is it finished. I'm not positive though. So, okay. Let us look at those events. So we want to now go system event ID. We can delete this running query. And it was 327. And the log, I think, was application. There we go. So we can see the data. So the event data, it looks like the 1, 2, 3, 4, 5. The fifth parameter is the location of NTDS.DIT. That is in a shadow copy place since that's like a snapshot. Let's see, is there any other task datas? There we go. That's the path that even Hayabusa told us earlier, right? We could have just answered this question really quickly if we just remembered we ran Hayabusa and it told us where that dumped. Let's see. I'm going to look at 327 or 326 since that was 327. Logs attached. Let's see. 1, 2, 3, 4, 5. DFSR. So it looks like this event is slightly different. DS token. Don't exactly know what that file is. DFSR. Does this one have an NTDS even? Let's see. What I'm going to do is a -c, grep-i, NTDS.DIT, and then JQ dot. We need to make sure we have a space with the -c. There we go. So this is the snapshot, and that's it. So 326 is not showing us the actual file where it goes to. So I'm going to guess that 326 is it started the backup copy, it's pulling it out of this directory, and then 327 would be it finishing. But again, that's all my guess, right? So let us see what the question was, and then I'm going to create a chainsaw rule in order to automate this. So let's see, full path. Okay. So let's go with 327 JQ. Let's create a rule file to extract this because it's got a these double slashes, and I think it would be just a pain to extract that with JQ. It would be quicker just to erase them. But what we could do is create the hunt file and then not have that to begin with. So when I was looking at chainsaw hunt files, I'll show you like how I went to learn this because this is something I just learned about today. I didn't really have much experience creating these. I was just looking at like how they worked. So I went to a hunt file. Let's say login attacks, account brute force, and then we can see how it's structured, right? We got a title, we got a grouping, description, the author, the kind of files are evtx. This could be MFT, things like that. The level you want to give it, the status, the fields. So this is going to rename fields. So we take the event system ID field, rename it to event ID so it's much more user friendly. And then we give it a condition. So we have condition, failed logins, and not empty. So we got two things, failed logins here, which is going to be a 4625, and empty is going to be username is null, right? And this means it wants more than 5 of these. So we got an aggregate as well. So you can do like counts, things like that. This is just giving us a good explanation of the rules. If I wanted to know more about filters, I just did like a grep-r filter and then let's do 5. And let's do it to less-s. And I kind of just looked around at all the filters here and got an understanding how it's structured, right? So I'm going to make a directory here. Is it camel case? No. Let's do make dir. I'll call it shadow copies, I guess. That seems like a good name. And then we can cp login attacks, account brute force. If we do a find.-type f, there's not really a strict naming convention. I like the event ID and then a description. So that's the one I'm going to use. So I'm going to cp, let's just do the login one again. And then we'll call this, what do we want to call it? EID 327 NTDSUtil Dump NTDS. That seems fine. .yaml. And then let's edit it. So we'll do EID 327. And this title, let's call this NTDSUtil Dump Complete. Group, we'll call it shadow copies is what I called it. Description, Active Directory database has been dumped, I guess. I don't know. Author, ipsec. Timestamp, that should be fine. Event fields, we probably want the event ID. The user's fine. Let's see. We probably want to get the computer. So name, computer. And let's look at this log file again. Let's see. HTB CrownJewel2 JQ. We probably want, this is 327. Okay. So the computer right there. Chainsaw, rule, shadow. Okay. So the field is computer, and that is the event system computer. Then name, dump location. And I don't know if this is going to be accurate or not. We could just do the entire event data, but that field is a little noisy, right? I don't want to dump all of this. So I'm going to count 1, 2, 3, 4, 5, and we'll dump the 5th field. And since it starts at 0, it'll be like the 4th, it'll look like 4, but it's really the 5th. So let's do event data 4. So that'd be the 5th line. And that should be good. Now we want to do filters. So I'm going to say it's going to be a NTDS file and not snapshot path. Because I want to only get the dump location. I don't want to get where it was snapshotted from. So we'll say NTDS file. This will be event system event ID 327. And then event data 4. And then we'll say NTDS.DIT. And I discovered you could do wildcards by just like looking at the previous rules, right? When we did that grep-r. And then we'll say snapshot path, because I don't want all that noise. So do this. And then we'll say $snap like that. Awesome. And then we'll delete the bottom of this because this is from the failed logins. And we have a rule file. If we did this correctly, it'll look really cool when we do a hunt command. So I'm going to specify the hunt, just the same exact command we did before, but now we have an extra rule. So hopefully it works. If the demo gods are in my favor, we did this all correctly. Go to chainsaw. Let's scroll up to the hunt. And this is going to be, yes, it is. So right off the bat, NTDSUtil Dump complete, event 327, and there we go. We have the dump location. So that is a quick foray into creating signatures. I don't know if this signature is good. After this video, I'm going to spend more time learning more how to create the rule file. So if you are watching this, I would highly recommend going to github.com. What is it? I forget exactly where it is. It's in with Secure Labs. If you go here, look at the rules. Hopefully the rule I created will appear here, and you will see a more up-to-date rule that may have less false positives or a better like targeting thing. But that's where I'm going to leave it. Hopefully you enjoyed how to create that event. And what we forgot to do is run it and actually grab the data. So I'm going to say, can we output it to JSON? Will this work? It does. Awesome. JQ dot NTDS. And this looks exactly like we had it before. Well, it didn't really save me any time. I was hoping it would be easier to just dump this without all the verbosity, but oh well. We will paste this in and see if it works. Submit. There we go. Task 3. When was the database dump created on disk? Oh, well, that's easy. We had this. So going back here, let's grab this timestamp, copy, paste, submit. Uh-oh. It's wrong. Do I have the timestamp wrong? What format does it want? Year, month, day. That looks right. Huh. Hour, minute, second. So it looks like it may be wrong. So let's now go take a look at exactly what we could have done wrong. So let's go back to this command. And let's see. That looks right. 59, 39, 58 is in that one. Okay. Are there other timestamps? Don't see them. Is there anything in this event data? No. So I'm going to take a look at the next question. When was the dump considered complete and ready for use? Is that this time? Awesome. So it looks like the dump gets created, and then it probably takes a couple seconds or minutes for it to be considered complete. So we want to look for when the actual dump started. So we're going to look for like the file create event on this. So let's see, what can we do? I'm going to take away this event ID filter. And then let's JQ it. And let's see. I'll probably go from the top. And what event are we at? So event 216. We got LSAS, and then it's doing this. 216 again. LSAS. I don't think those would be the completed. That's like, it's like kind of starting the job maybe. I want to look for the path where it has the actual directory. We could probably change our grep up. So grep NTDS.DIT, grep temp. wc-l. I did spell that correctly. What was the path? TMP. Okay, we got 3 events that have the full path. So this is probably the correct way. Now let's JQ dot less, and let's see. So the first event ID is 330. And we have the data here. Then we have, what event ID is this? 325. Data here. So we want to look at what these events are. So event ID 330, let's see, ESE NT 330 event. So 330, I don't think that's, is that task scheduler? Probably should just open up Windows at this point and look at those events. Yeah, that's definitely not the event log we're looking at. Let's see, event 325. Is there better information on that? Already went to that blog. Let's go to our own blog on Hack the Box and see if we say. So 325 and 327, an application log. So 325, the database engine created the new database. This is probably what it is. So if we were doing this in the event log viewer, we would see more data, which would be nice. Detached is that. So that's nice to know. So 325 is started. So I'm going to go and edit my hunt command, actually. So we can CP this to be 325 as well. And you kind of want both because maybe it never detaches. So I would actually do both. So we'll do Active Directory dump begin. That is all good. 325. Okay. Let's go back to hunt. And again, change our size. Why do we say begin or complete first? I guess I forgot one thing, but there's a different timestamp. 56. We'll try this timestamp. So it took 2 seconds. There we go. Awesome. So that is the answer there. And we want to fix the tool, the thing real quick. So this is NTDS Dump started. There we go. And hopefully you kind of get the value now in doing Sherlocks to do this. Why is user there? User doesn't have anything. I just noticed that. User. Event data, target username. Did I screw that up? Oh, that was probably in the thing we copied from. There's no username in this log. At least I don't think. Do we have a username? Does it tell us who did it? I don't see. Nope, I don't see a username. Is process ID useful? Nope, 00. Okay. So that's good. Let's go to the next question. Event logs use event sources to track information. And let's see. I don't have a full capture of the event log. This one's easier to answer if you had the Windows event log in front of your face. Let's see. Windows event log example. Let's go to images. I know I probably should just open up my Windows thing, but the event log has something. Is this it? Where's the question? What's it asking? Why is it going to YouTube? The event log source is going to be the provider attributes in Chainsaw. If you open up event log, it's relatively like it says the source. I don't know why Chainsaw calls it something different, but that's the answer. So that one is a little bit tough if you don't use the native Windows event log viewer, but we'll just hand wave that because I've ran into that issue before. So let's see. When NTDSUtil is used to dump the database, it enumerates users and groups. What are two groups enumerated by the NTDSUtil.exe process? Give the group names in alphabetical order, joined by comma space. So let's go back to CrownJewel2. So I'm going to cat CrownJewel2, look at the security log, and I'm going to guess we want event ID 4799 because that's an account was enumerated. So let's go back to our JQ queries where we had event ID. There we go. And we want 4799. This is going to be the security log. We don't need NTDS.DIT. So if we just look at all these, JQ dot, we have the caller process name and then target username, group, and whatnot. Username can also be group names. So we have backup operators there. So we want to look at where the process name is probably going to have NTDSUtil, right? So I'm just going to do a grep NTDSUtil. There we go. Then we can JQ dot. And now we have all the ones with caller process. I could have done went in and did my select just like I've done before. But sometimes I like just being able to use grep because it's quicker. So now we just want to get all the event data, target, user name, then sort-u, administrators, and backup operators. So those are the two groups. So if we look, administrators, backup operators, submit. There we go. And the final question. Now you're tasked to find the login time for the malicious session. Use the login ID, find the time when the user login session started. Okay. So this one, let's see. Let's grab everything here. And there should be a logon ID, which is this. And we're going to look at for all events with this. So JQ dot. Let's do less. And let's see. I'm going to change up my query a little bit. Let's get a list. I'm going to say, what do I want? We'll do system event ID and then event data. There we go. So that's a little bit compressed so we can quickly see. And then let's less this. And we have event ID for all these are 4799. Let's get rid of that because all we want to look at is the security log. So event ID 5379. This is some Windows Live thing. It could be this time. I think this is when it started. I guess let's try this real quick. Get rid of the filters so we can look at the time quickly. This is system time created tribute system time. Okay. System time created tribute system time. There we go. Let's see if it's this time, the very first event. I don't think it would be, but it's possible. It is. So we could look at the first event because that's when they like attempt to log in, right? But Normally, that's not the event I go off of. It may be the same exact time just because everything happens so quickly. Here we see that create shell unelevated task, but there's something else I wanted to talk about real quick before we wrap this video up, and I promise you, you will like it. So let's see, 4799, subject username, login ID. So that is, let's see, 4799 appears a lot. I should go back and add this because we don't care about enumerating groups right now. So we can say system event ID does not equal 4799. And that did not work because I did not say and. There we go. So Windows Live Login, that. This is, again, that task. I am not getting the log I expected. I thought we'd be able to see like a Kerberos ticket. Let's see. I may pause the video and come back to this if I don't see this. Ticket opt, is that it? Did we get lucky with the login session? Maybe the login session isn't part of the Kerberos thing. The login UID or ID is not here, so that's why I wasn't seeing it. Okay. So maybe I did it the correct way. But I always like looking at the Kerberos stuff. So that maybe got you the time. I'm just going to grab what I want. So this is going to be 4768. I forget exactly what Kerberos event this is. I think a TGT is being created. But the key thing I want to just talk about really quick. Whenever I look at TGTs, I always look at this field, the ticket options. If I see 408, then 00010, that's probably going to be Rubius. If it is 508 and then all zeros, I think that's going to be in packet. Sometimes you have this bit off, so it'd be 408100000. But the key things I look at is right here, this one being a 0, so 4080 would be Rubius. Again, in packet, this would just be, I think 508 is in packet. But these are just the Kerberos tickets being created. The ticket option is all the parameters. So if we went to like Olaf, Kerberos, calculator maybe? Is this it? No. What is the link? Maybe it's TGT. It goes to his Twitter. Or X account, I guess. Let's see, is this his post about it? It's funny that, yeah, this is it. So this is a really good link, linkshare.olaf Harton. I'm not even going to pronounce his last name, but the TGT calc is really good for understanding what the ticket options mean. So if we grab this, put this in, we can see all the ticket options. So name, canicalize, renewable, okay, affordable, and renewable. That's one of the more common ones. Rubius doesn't do that flag, I believe memory serves right, which gets rid of this field. And in packet, they do a 5 there and nothing there. And they do proxy, affordable, renewable. So this is a good calculator if you just want to understand what each field is in the Kerberos thing. And of course, you can go ahead and Google what the field is to understand like the purpose of it being in that ticket. But that's a good thing to look at. Encryption type, 0x12, is that, what is 0x12 to, I think that's 18. So this would probably be, I think, AES, Kerberos encryption type 12. See, I know 23, which I think would be 18 in hex, would be RC4. What are the encryption types? Yeah, RC4. So these would definitely not necessarily be suspicious. Windows does RC4 a lot by default. 0x12, this would be AES. Generally, you see attackers using the RC4 quite frequently because when they do a curb roasting attack, they want to go ahead and crack it. So they request as weak of an encryption type as possible so it cracks faster, right? You could use Impacket to do a curb roast attack and request a AES ticket, but it's just going to take a lot longer to crack. It'll be much more OPSEC friendly because it's not going to stick out. I know a lot of defenders, when they see these encryption types, they start like, that raises a flag and then they go investigate it more. But yeah, hopefully that makes sense. And that's enough rambling for me. I'll wrap up this Sherlock and hope you guys enjoyed it. Take care, and I'll see you all next time.